So remember, we're gonna have Matt. Since you missed the part about where to use polar coordinates in your life, I don't know a ton about it, so we're gonna have to just do a little paper on it. If you don't mind looking it up.
He's like, okay, I'm sure.
So Matt's gonna report back to us.
Good
Anthony will do a brush.
I guess.
He would do it. But so polar coordinates. Okay, guys. What we're going to use polar coordinates for is it's just another way to represent points in a two-dimensional plane. There's a connection between rectangular coordinates and polar coordinates where we change rectangular coordinates to polar coordinates by using some trigonometry. So that's the connection to what we've been doing. The polar coordinate system has an origin, if you could write this down, has an origin, which we call the pole, and a ray. Remember, a ray is just starts at a point and then goes off, has an arrow showing its direction it's going in. Yeah.
We just got this.
Right, so it has an origin pole and a ray called the polar axis. Looks like this. Polar coordinates I don't think this thing's working at all for that. Yes, we've noticed. See what it does here.
Oh, that's cool. I think the math house happened today where we should just call it quits.
Yeah.
All right, Rouse, can we go home? Today's a natural weekend. I was like, all right, I'm going to
Lots of them.
I had like stuff packed up and like grabbing out and I was like, wait a minute. So we started no, it's
Okay, so on the next one there, polar coordinates. Polar coordinates. They're of the form r comma theta. So please write that down. They're of the form r comma theta. R comma theta. Yes. R comma theta. This is in the next one, which is polar coordinates, where r is the radius or distance from origin, and theta is the angle. See if I can get it to work now here.
there it is.
Yeah, there it is. This little symbol right here is a such that symbol. I don't know what this is.
Wow.
All right. It's all recorded too. All right, so we can all experience our technological frustrations here. So we'll just keep recording. I'm not sure I'll re-record it tomorrow first period if we need to. Still thinking. Okay, so you got that down for polar coordinates? This right here means such that and then if you could, why don't you go ahead and see if you can plot these points. See if you can plot the points. What I usually do is use the angle first. So pi over 6 is the angle. Where would pi over 6 be located here? This first ray up. And then I'm a distance of 2 out. So that is the point 2 comma pi over 6. What about the next one? If I do an angle of negative 4 pi over 3, we're going to go in a clockwise direction, right? 4 pi over 3 is going to be past the negative pi, so I'm going to go over halfway through the circle. And then am I going to be high or low on the circle? Negative 4 pi over 3. High on the circle. And then I'm just 1 out. So it's right here. Is my point 1 comma negative 4 pi over 3. So go ahead and plot that point. You could put A, B, C, D. What about C on here? 5 comma negative 5 pi over 6. So
7 pi over 6.
okay, negative 5 pi over 6 would be the same as 7 pi over 6. Yep. So it's going to go around over to here, and then I'm going to go out 1, 2, 3, 4, 5. So this is the point 5 comma negative 5 pi over 6. And then the next one, we're going to do an angle of 3 pi over 2 first. So 3 pi over 2 would bring me all the way around to this ray right here. So going all the way around this way over to that ray. And then I'm going to go negative 5. So what that will do is send me in the opposite direction, right? So I first go all the way around to 3 pi over 2, but then I'm going to go 1, 2, 3, 4, 5 up to right here. And that is the coordinate, the polar coordinate, negative 5, 3 pi over 2. And then negative 3 pi over 4, I would go in this direction, all the way over to here. So I'm on this ray. Okay. But the negative 3 sends me in the opposite direction. So this would be the coordinate, negative 3 comma 3 pi over 4. I'll move out of the way here. So we go around negative 3 pi over 4 to here. It puts us in the third quadrant. And then a radius of negative 3 would send us back in the opposite direction, 3 units away from the origin. And then negative pi over 3. Negative pi over 3 would be down here. Negative pi over 3 would go this way over to here. So I'm somewhere along this ray, right here. And the question is, how far out? Well, 1, 2, 3.5 out. So that puts me right here. So my coordinate here would be 3.5 comma negative pi over 3. So that's how you plot polar coordinates. So if I gave you an equation or a function in polar form, which I eventually will, you could plot some points by plugging in different angles from the unit circle that tell the value of. So you might plot points like 0, pi over 4, pi over 2, pi over 6, pi over 3. Okay. So that's how we figure out. Although the calculator will do all this for you, so we can investigate a little bit with the calculator. Could you, right now, list 4 other pairs of coordinates for 2 comma negative pi over 3? So if I had a point at 2 comma negative pi over 3 on the polar coordinate grid, maybe I'll do it up here. We'll reuse this grid. So in red, I'll do 2 comma negative pi over 3. So I'd be negative pi over 3 out and 2 down. So here's the point right here, 2 comma negative pi over 3. Could you give me, and you can work with another student on this, 4 other pairs of coordinates where you just change the sign, say of r, maybe you keep the sign of r the same but change theta's sign. That will make you land at the same spot. Or change the sign of r and keep theta the same, or change the sign of r and change the sign of theta. So you can get, see if you can get 4 other pairs besides that one that are equivalent or will land you at that same spot. So go ahead and take just a couple minutes to do that right now and check with the person next to you. So if we go to our calculator, we're going to take our calculator and investigate what a polar graph looks like rather than make a table and plug in values one at a time. You will change your mode right down here from function to polar. So there's polar, and then you can quit out of there. You can leave it in degree, you can put it in radian, it doesn't matter. I'm going to leave it in degree. Hit second quit, and then in your y equals menu, just enter in r. Well, that's the y equals. I should be in, I don't know why it's not showing r. I didn't select it. Right. When you switch to polar, it should say r. I didn't hit enter. Second quit. So y equals, there it is, r equals, and type in 2 cosine of theta. And when you type the xt theta n button, it knows to put in theta instead of t. And then in terms of the graph, if you just hit zoom and just start with z standard, number 6, it's actually graphing. I know it's distorted a bit, but do you know what shape that is?
That's an ellipse.
It looks like an ellipse, but I don't think it's an ellipse. How far do we go in each direction here, vertically and horizontally?
1.
Okay, so what do you think it might be then?
Circle.
Yeah, it is.
Why does
So just graph, well, it depends on what your window is. So if you want to, you can change your window. See the window, it says 0 degrees to 360 degrees. That's my theta. There's the change in theta is 7.5 degrees at a time. If you want to, you can change your x min. This might help. Change your x min to -2, not 20, but -2, and change your x max to 2. Keep your scale at 1. Change your y min to -2, and your y max to 2. If you don't keep a square window, it really will look distorted. As you can see, if you change it to -2 to 2. It looks to be a circle. You know, a circle is a special case of an ellipse. So,
So I was right. Okay.
yes.
That's what I thought.
Right. So that's how we graph in polar form. Right, so if it says on number 3 to convert from polar to rectangular, the relationship we're going to use, or relationships, would be x equals r cosine theta, and y equals, going back to our picture here, r sine theta is the y coordinate, which we've seen before. So let's go ahead and see if we can convert these. It's just a matter of plugging in. So here, you guys here with me? Everybody with me? Okay, so we have 2 formulas for changing from polar back to rectangular, and then we'll do rectangular to polar. So this is my r, and this is my theta. With that in mind, x would equal 2 cosine of pi over 6, and y would equal 2 sine pi over 6. Just plugging it in to my formula here. So what is my x coordinate that's equivalent to 2 comma pi over 6? Yeah. 2. We have 2, and then cosine of pi over 6 is actually root 3 over 2. So it's not 2, but root 3. And then 2 sine of pi over 6 would be 2 times 1/2, which equals 2. So we've just taken a polar coordinate and changed it to rectangular. Okay. Any questions on that? You might want to put a box around this. This is our conversion factor here. Yes.
Did you say 2 times 1/2 equals 2?
Equals 1, sorry. Yes. Thank you, Cameron. Starting to do arithmetic like some of my algebra students here. So 2 times 1/2, the 2's cancel, we get 1.
Rounds out of it. They don't get it.
No. All right. X equals, we have r, which is -8, cosine of 3 pi over 4, and y is equal to -8 sine of 3 pi over 4. So we'll convert these polar coordinates back to rectangular. So I have -8 times 3 pi over, cosine of 3 pi over 4 would be second quadrant, So it's negative root 2 over 2. And sine of 3 pi over 4 is going to be positive root 2 over 2. And here's where our unit circle stuff comes in again. So what are my coordinates when I change this one from polar to rectangular? What does this simplify to? Four root 2, yep. And comma, negative 4 root 2, yep.
I did it.
So, okay, once again, thinking about where negative 8, comma, 3 pi over 4 would be, let's just take this graph up here that we already have. It's going to go off this graph, but negative 8, comma, 3 pi over 4, I'd go around to 3 pi over 4, and then, so I'd be along this ray, but somewhere along that ray, but the negative 8 takes me in, flips it back this way, and so negative 8, comma, 3 pi over 4 would end up being in the fourth quadrant. Look at this coordinate here, guys. This is important. Everybody looking up here. This coordinate would be in what quadrant?
4.
Right 4 root 2, down negative 4 root 2, right on top of this thing in the fourth quadrant. Okay, so that's what we're doing. We're taking the point, okay, this point, 8, comma, negative 8, comma, 3 pi over 4, and changing it into rectangular form. As we oftentimes do in math, we got to go in the reverse direction. Okay? So I'd like you to write down the following two relationships here. R squared equals x squared plus y squared. Okay, r squared equals x squared plus y squared. We're going to use that to solve for r. If you'd like to, you could just solve it now. R equals square root of x squared plus y squared. It's really plus or minus, but we'll apply the appropriate sign depending on what we want to do with it. Remember, r can be plus or minus. And then the other relationship is tangent theta equals y over x, or theta equals inverse tangent of y over x if you want to solve that for theta. Okay, but these are the relationships that we use for changing from rectangular to polar. And some of you may want to just take the approach that you're going to draw the picture and use trigonometry to do it. That's really where these formulas come from, is from our trigonometry, right triangle trigonometry. So that's usually the approach I take, is I'll go and take this coordinate, 2 root 3 comma negative 2. I'll draw it, just a rough sketch of it. We're going out 2 root 3 and up or down negative 2. So it's actually farther out than it is down. So let me see if I can be a little more accurate here. I'll move out of the way. So I'm going, oops, I went the wrong quadrant. Let's try that again. So 2 root 3, negative 2 would be maybe somewhere over here in the fourth quadrant. So we've got 2 root 3 and then 2 down. So negative 2, 2 down. It should be a little farther down. Not that extreme of a difference. But theta is right there. That's where theta is located. Okay? So an r is this hypotenuse of my right triangle. So all I've done is I've drawn the legs of the right triangle that represent the point 2 root 3 to the right and negative 2 down. So really these formulas are just doing the trig to solve this right triangle. Although we don't need to solve the whole thing. We just need r and we need theta. We don't need the other two angles, okay? So solving the triangle, we find all 6 pieces. We don't need that. So r is equal to the square root of 2 squared plus 2 root 3 squared. So I've got 4 plus, do you know how to do 2 root 3 squared? 2 times 2 is 4, and then root 3 times root 3 is just 3. So we end up with 4 plus 12, which is 16, which gives us an R of 4. Well, it's going to depend on what angle we use. If we use a positive angle, we can just use a positive angle between 0 and 2 pi. And if we are at the correct angle, we can leave it positive. But you're right, it could be plus or minus 4. For the reason that we were able to find 4 pairs equivalent to this guy up here at 2 negative pi over 3. So R is 4. What's theta equal to here? Now here's where we have to be careful, and this is where we need to think in terms of positive or negative. When I do, go ahead and do this on your calculator. Inverse tangent of y, in this case y is 2, and x is, it's actually negative 2, and x is 2 root 3. So theta is equal to inverse tangent of, do you see why I put negative 2 in? Okay, on my picture, I just have written the length, but the y-coordinate here is negative 2. So this 2 is negative. I'm just plugging in the points here. Here's x, here's y. Now, when I get the functional value of inverse tangent of negative 2 over 2 root 3, my calculator is going to give me a negative angle. Because if you recall, the range of inverse tangent as a functional output is between negative pi over 2 and pi over 2. So these were the x out zones. It's going to give me one of these two. So what angle does your calculator give you? Negative 30. So theta equals negative 30 degrees. So my coordinate in r comma theta would be 4 comma. Now, if we change negative 30 degrees to radians, what would it be? Negative pi over 6. And that's how we're going to do it. We're going to be using radians when we change from rectangular to polar most of the time. But you should be able to go back and forth between either one. Depends on the context. So that's changing from rectangular to polar. You've got to find r, which is the radius, and you've got to find theta. And remember, this is not a unique value. We could find, there are lots of equivalent values to this, an infinite number of them. Because every time you go around 2 pi radians, you land at the same spot. All right, B. Let's go ahead and find R here. Can you guys go ahead and find R for problem B there? And then I'd like you to find theta for me. So go ahead and try that on your own, please. We have 9 plus 3, right, which is 12. Root 12 simplified would be 2 root 3, and they're going to write it in simplified form if you're checking your solutions. So root 12 would be 2 root 3. Theta is equal to inverse tangent of y, which is 3, over x, which is negative root 3. You guys might recognize this, maybe, as inverse tangent of negative, if I simplify this, I'm going to multiply by root 3 over root 3, right? So it'd be negative 3 root 3 over 3, which is equal to inverse tangent of negative root 3. So you may recognize that. Okay, it's a special angle on the unit circle. What is that special angle? Negative 60 degrees, okay. Which also is negative pi over 3. That's when we have, so we have 1/2 over, see, cosine would be the, never cosine, yeah, the first one, so cosine over sine. So we'd have, sine would be the root 3 over 2 on top. Cosine would be the 1/2 on on the bottom, and the 2's would cancel, leaving root 3. So it's negative pi over 3. So changing this to polar, it would be 2 root 3, comma, negative pi over 3. I may ask you guys to do this without a calculator, in which case I'm expecting you to recognize the special right angles, okay? All right, any questions on this? Converting from rectangular to polar. That's primarily what you're going to do for homework. Although the way I have the homework set up, you could go either direction, whichever you're comfortable with. But you got to be able to go back and forth, okay? Polar to rectangular, rectangular to polar. That's the goal today. All right, just a little bit about graphs. What does the graph of r equal a look like, do you think? What does r represent?
Radius.
Yes. So if all I give you is a radius, what kind of shape will you end up with when you graph it? A square. Not quite a square. I heard it. A circle, yeah. So radius is set, but the angle can be anything. So r equals 3. What will r equals 3 look like? It's a circle of radius 3. So there's r equals 3. And we'll do it on the calculator just so that you don't have to just trust me. And then theta equals b. The angle is set, but the distance from the pole could be anything. What do you think that might be? So theta equals 5 pi over 6. If I were to draw that, 5 pi over 6 is somewhere over here. But then it can also go infinitely in that direction. So yes, it is a line. Theta equals 5 pi over 6. So just a little bit on graphs. We're going to be doing more with graphs of these next time. I think today we're just going to focus on, can you change rectangular coordinates to polar and polar to rectangular, and at least have an idea of how to plot them on the coordinate plane. Leave it at that.